Hey guys, Mr. Bowman again. We're up to task 2 of our practice task. And task 1, we've done each of the 5 sections. And task 2, they've extended this. They've come up with the idea of changing our proposal based on certain factors. So just to recap from the question. So the question has asked us to increase the entertainment value. So increase the entertainment value of our plan. It's told us this new section must have a maximum height of 10 meters. And it has also specifically told us the start point must be at 51,0, and that's the end point of the previous section. And it's told us about the finish, and it must finish at 70,0. So those are the criteria that we've been given it. Let's go through this task in a bit more detail. So it's asked us to design a new feature. So the first thing I would be doing is I would just be mentioning, well, what am I trying to achieve here? So I would like the final section to continue the wave from the previous section. So I would like the final section to continue the wave from the previous section. So I really liked what they did on the other slide, but the only thing is, so I want that to carry on, but the only thing is I'm looking at to be more dramatic as well. So let's use the pen mode on this one just to show us. So I want that to carry on, except I want it to be a lot more dramatic than it was at the end of that. So we can see how big that question is. Okay. However, so just noting that, however, to increase the entertainment value, value I would like it to reach a higher maximum and fall to a deeper minimum. I'd like it to reach a higher maximum and fall to a deeper minimum. So that's just explaining I want the wave just to be bigger in every way. Okay, and then the thing that I'm really going for is the finale, so to speak, of R1 would be an underground so it's going to be an underground VR tunnel with sound and VR equipment. So I'm really wanting that last bit to be very dramatic, lots of noise, and that should be depicting real life scenarios. And that could be stuff like plane crashes, maybe war tanks, something of that nature. So that's what I'm going for. That's kind of the design that I want. So what would that look like as a graph or a model is the next question. So let's draw our graph. So there that is, there's a break in the scale there, and that point there, well, that's 51,0. That's our start point. So what we said is we're wanting it to go up really dramatically, down really dramatically, and then finish up at the end, and that would be 70,0. So there are start points. So I said I like this wave function. So what that means is we're probably going to be using a trig graph, which means the middle value would need to be directly in the middle. So let's start looking at the features of this graph before we actually get into more detail. So as we'll go, I'll label the features. So the features, it must have a domain of 51. Oops, sorry, domain of, so it's between 51 and 70. So that's given to us in the context. So that has to happen. It will need, as a result, x-intercepts at 51, 0 and 70, 0. So they're the start and end points. And in addition to that, another x-intercept at, what's that x-intercept? So it'll be 60.5, 0 to go to the underground VR tunnel. Okay, and what I did is I calculated that part there. So that's the very middle point between those two graphs, because we will most likely be using a trig graph. So we've got the x-intercepts. The other features that are required, we will be needing a maximum of 10 meters. So as a result, we need a maximum at, that was 55.75, 10. So that's this point up here, 55.75, 10. And I did that, that's the direct middle between those two x-intercepts there. So we need that maximum there. And that will also mean a minimum at 65.25, 10. So that would be that value there, 65.25, 10. Other features would be an amplitude of 10 units. And that's because the maximum and minimums at 10 and -10 respectively. What else we're going to need? We can also chat about the period, or how long it takes to complete that full cycle. So a full cycle takes 19 minutes to complete. So don't forget 19 minutes, that's the x-axis, or the variable on the x-axis to complete, and that's 71 minus 15. And it doesn't appear, so if you think of a trig graph, that's centered around the x-axis. So no up or down movement. And what I'm going to do is, assuming we're going to use a sine graph, the 0, 0 interception has been moved to 51, 0. And what I mean by that is a sine graph normally looks like this. 0, 0. And what I'm suggesting is this point has been moved this direction, and it's going to end up as this point here at 55 or 51, 0. So it looks like it's gone through all the features, but just to recap, that's our start point and our finish point, which we were given. Start and finish. That portion there underground, that's our VR underground tunnel. And the point up there is our maximum of 10 meters. So we can kind of see how this graph relates to those 4 things we identified at the type. The entertainment value, well, that's the finale with the underground VR tunnel. The maximum height, well, we've got that there. The start at 51, 0, and finally the finish at 70, 0. So hopefully you can see how I've used all that context and all that criteria to form a graph. So what I am going to do is I'm going to change pen color. Let's go to green. Let's actually come up with a model for this equation. So we already said below that we were going to look to use a sine graph. So y is going to be equal to a sine bx plus c plus d. So let's have a think. We have gone through all of the features. So the amplitude is the a value. So a is going to be equal to 10. So we've got that part up there. We've been told a full cycle takes 19 minutes. So that means 360 divided by 19 is how many 19-minute revolutions will fit into that 360 degrees. So again, I've assumed it's degrees here. Just to note, if it was radians, you would have been doing 2 pi divided by 19 to get that. But I'm assuming it is in degrees because the context didn't say. Plus c, well, that relates to the left or right movement. So in our case, c is equal to negative 51 because we've assumed that 0.00 has been shifted all the way to positive 51. And the d value, well, that is 0 because we did note there was no up or down movement. So what that means is our final model, y is equal to a. Oh, sorry, we've redone a. So y is equal to 10 times sine 360 divided by 19. So note that's definitely in degrees. X minus 51, close bracket, and then close the big bracket. And just note, this is only relevant for values of x that are between 51 and 70. So any values below 51, any values above 70, this won't work. Just because we're not sure what the roller coaster is doing before or after that, or they're doing something different. So hopefully you found this video on task 2 useful. What we did was we mentioned the criteria that we were looking for our model. I've briefly mentioned the design, what I'm looking for. I wanted a big wave, but I wanted the maximum to be higher and the minimum to be lower. And I was wanting that underground VR section to depict real life scenarios with sound and video recordings. I then mapped that in the graph. So I've got the graph there with the blue 4 features that I mentioned. So it's got a start and end point, it's got the underground tunnel, and it's got the maximum height of 10 meters. And then I went through all the features of the graph. It had a domain between 51 and 70. It had x-intercepts at 51 and 70 because they were the start and end points we were told about. We had another x-intercept between those to make sure the tunnel then gets underground at 60.5, 0. We had because we decided on this wave or this trig function, that gave us a maximum at 55.75, 10. So we've got that 10 meter maximum. As a result, we also had a minimum at 65.25, negative 10. That gave us an amplitude of 10 units. A full cycle took 19 minutes to complete. There was no up or down movement of this trig graph. And we're assuming it was a sine graph or sine function. It was moved across to positive 51. So hopefully you found this video useful. And just want to note the key things you needed for merit are you did need your correct model. And you did need to link that model with context. And that's what I've done there. And I've also written and discussed it up the top in the design features and on the right in the features section. Okay, so if you haven't got this down, make sure you take good notes and then keep an eye out for video number 3 that discusses the excellent section.